Welcome back to the deep dive. So you've sent us a great collection of sources on Terraform's foundational architecture. And this is the kind of stuff that I think really changes how you approach writing infrastructure as code.
It really does.
We're moving beyond just, using the tool. We're getting into how the engine actually works.
Exactly. I mean, when you run Terraform Applied, there is so much incredibly sophisticated work happening under the hood. Our mission today is to peel back that hood.
Right.
We're going to try and understand that structural separation that makes Terraform so successful. How does the static core logic, the brain, talk to the specialized, always changing providers that do the real work?
And that separation is really the key to its incredible universality, right? You can manage AWS, Azure, Google Cloud, but then it also handles things like Cloudflare or Datadog or even Kubernetes.
All of them.
So if you want to know the how behind that flexibility, it all comes down to what the sources call the plugin-based architecture.
And that framework, that's the secret sauce. It's what lets one central tool, TerraformCore, stay stable and lean, while the specialized parts, the plugins, can evolve at the blistering pace of the modern cloud.
Okay, let's unpack this architecture because it's the very deliberate split. When we talk about the internal structure, what are the two distinct parts and who handles what?
We have to draw a really clear line between Terraform Core and Terraform plugins. If you think about it like a construction site, Core is the project management office. It's that static binary you download.
The orchestrator.
The orchestrator, its whole purpose is high-level strategy.
So what does that high-level strategy actually look like technically? What are Core's specific jobs?
Core handles three critical things. First, HCL parsing, so reading and validating your configuration files.
Just reading the blueprints.
Exactly. Second, it builds and manages the resource graph. And this is the single critical timeline. It's the map of dependencies that decides the order things must be created or destroyed.
You can't launch a VM before the VPC is there.
You can't. And Core manages that relationship across everything. And third, and maybe most importantly, Core manages the state file. It makes sure your real world matches your code.
Okay, so the project manager reads the blueprints, organizes the timeline, keeps the official records. That leaves the plugins, which you said are basically the providers, right? The AWS or Azure executables.
They are the providers. And in our analogy, they're the specialized contractors. They're totally separate executables that Core treats as, a black box of expertise.
A black box.
Yeah. When Core decides a resource needs creating based on the graph, it just sends a standard instruction to the right plugin. The plugin then translates that into the specific proprietary API calls for that cloud vendor.
So Core knows what needs to happen, and the plugin knows how to talk to the API to make it happen. What's the technical handshake between them? They're two separate programs.
The crucial detail here is that they communicate using RPC, Remote Procedure Call.
Ah, okay. RPC.
This is absolutely foundational. When Core executes a plan, say, create this database, it wraps that instruction up and sends it over a standardized RPC connection to the AWS provider executable.
And the provider just listens for that.
It listens, unwraps the message, knows it needs to talk to the RDS API, does the work, and then sends an RPC response back with the status or, any output variables.
What's so interesting about that is Core doesn't need to care if the AWS API is REST or if Google uses gRPC. It just sends its standard RPC message.
Precisely. And that has huge implications. Speed, stability, future development. Since the communication contract is stable, providers can be written in any language that supports RPC, Go, Python, whatever. It really speeds up new provider development.
But wait a second. If you have these two separate executables constantly talking, doesn't that create latency? Or risk? Wouldn't it just be simpler architecturally to combine everything into one giant binary?
That is the single most important question you can ask about this. And the answer is that combining them would guarantee stagnation. It would be a mess. By keeping them separate, providers get their own independent release cycles.
Oh, okay. I think the light bulb's going on for a lot of people right now.
Just think about the pace of change. AWS rolls out, 100 new features a year? If Terraform were one big program...
A monolith.
A monolith, right. Every time the AWS team or the Google team changed an API, you'd have to download and update the entire TerraformCore binary.
Just to deploy one new resource type. That's a maintenance nightmare.
It's a total nightmare. Keeping them separate means Core stays stable, and providers can ship updates daily if they need to, with no interference. It keeps the Core engine lean, stable, and universal. And that's exactly what you want.
That separation really does allow for that specialization and rapid iteration. So let's take that theory and apply it to how we actually build things today. Environments that rely on multiple vendors.
Yes, because this is where the plugin architecture really, really shines. I mean, nobody builds a digital planet using just one company anymore.
So how does the configuration handle that? Does my workflow get all complicated? Do I need, like, separate projects for each vendor?
Painfully, no. And that's the beauty of Core's orchestration. In a single directory, in a single .tf file even, you just define the provider blocks you need. An Oz block, a Cloudflare block, a Datadog block,
All in the same file?
all in the same file. Core just loads all the necessary plugins and treats them as available tools for that one deployment.
Okay, let's use a real example. I'm running a web service. I use AWS for my containers and my load balancers, but I'm using Cloudflare for my global DNS and for security, and then, say, Datadog for monitoring hooks. 3 different companies, 3 APIs.
That's a perfect real-world stack. So the question is, who manages the timing? That Cloudflare DNS record can't possibly point to the AWS load balancer until
Until the load balancer is fully provisioned and has a public IP address.
Exactly. So if the load balancer is managed by the AWS plugin and the DNS record is managed by the Cloudflare plugin, how does Terraform make sure the Cloudflare command waits?
And this must come back to the graph.
It comes right back to the resource graph, which is managed only by TerraformCore. Core sees the dependency. It sees that the input for the Cloudflare resource requires the output from the AWS resource. It doesn't care that they're managed by 2 separate independent executables.
So the data flow is fascinating. Core tells the AWS plugin, build the load balancer. The plugin reports back with success and gives it the ARN or IP as an output. Core updates the state file,
Right.
and then it uses that output to fill in the input for the Cloudflare resource, and finally sends the RPC instruction over to the Cloudflare plugin.
It's the ultimate middleman, managing dependencies across completely independent organizations. And that unified graph is so critical, it means you, the person writing the code, can truly pick the best tool for every job, the best security, the best compute, without any of the coordination headaches. And it avoids vendor lock-in.
So that's complexity across different vendors. But what about complexity within a single vendor? It's really common for a big company to be all in on, say, AWS, but they need to deploy the same infrastructure into 2 different places.
That's a classic challenge, yeah. You might need your London data center and a replica in New York, so 2 different AWS regions. Or, even more common, you have to manage your staging account and your production account from the same code base.
Right. So how does Core, which is designed to talk to one AWS plugin, know the difference? How does it distinguish between an instruction for the production account versus one for the staging account?
This is where you have to use the really powerful alias feature. An alias lets you define multiple distinct configurations of the exact same plugin.
It's like giving them nicknames.
It's exactly like giving them nicknames. It gives Core a way to attach a unique configuration, a different region, different credentials, a different profile to a specific instance of that provider.
Okay, walk us through that. The dev versus prod account scenario is probably the most common reason people hit this.
Sure. Let's say you have 2 AWS accounts. You define the Oz provider block twice in your code. The first one is for your dev account. This becomes your default provider. You just leave it unnamed.
Okay.
For the second definition, the one with the production account credentials, you just add 1 line. Alias equals prod. Now, Core knows about 2 distinct AWS configurations, the default one for dev and the one nicknamed prod.
So when I'm writing the code for, say, a really sensitive database, how do I tell it only go into the production account?
You target it explicitly. In that database resource block, you add the meta argument provider equals oz.prod. That simple suffix tells Core, hey, send this specific RPC instruction to the provider instance that you loaded with the prod alias.
And crucially, any resource that I don't specify an alias for just goes to the default, the dev configuration.
Exactly. Which is a great safety feature. It makes it much harder for developers to accidentally deploy something massive with the wrong permissions.
Right.
So the alias is how you get that fine-grained control. It's how you manage parallel infrastructure using the same code, which solves a huge headache in big deployments. It stops Core from getting confused when it's hired the same contractor, the AWS plugin twice, but with different sets of marching orders.
This deep dive has really, it's really clarified the engine room of Terraform for me. Let's try and synthesize this into 4 powerful takeaways for everyone listening.
Okay. First, the architecture. Just remember, Terraform is fundamentally split. You have Core, the orchestrator managing the graph and state, and you have plugins, the specialized contractors doing the API calls.
Second, the communication. They talk to each other using RPC, and that's what allows the core to stay stable and universal, no matter how complex a provider gets.
Third, the power of multi-provider configurations. Core uses its single unified resource graph to manage dependencies across different vendors. That's the mechanism that lets you avoid vendor lock-in.
And fourth, aliases. When you need multiple distinct configurations of the same provider for different regions or different accounts, you use the alias meta-argument to tell Terraform which configuration to use for which resource.
Those four nuggets are absolutely essential. It's what takes you from being a Terraform user to a Terraform engineer.
Understanding this architecture means you know why it's so stable and so flexible. We've hopefully given you the shortcut to understanding how to build these resilient digital worlds one plugin at a time. Thanks for diving deep with us.
And here's one final thought for you to mull over. We've established that the core handles the unified state and builds the graph, coordinating between separate plugins. So what happens if you're running a huge multi-cloud apply and the RPC connection to a critical provider, let's say the Cloudflare plugin, just drops out halfway through an operation? How does the core's graph ensure integrity? Specifically, what systems are in place to roll back or clean up partially created resources across different vendors and prevent drift when a crucial communication link just fails? Think about how robust that internal contract really has to be.